All right, welcome to the Explainer. Today we're going to dive into one of the most powerful ideas in object-oriented programming, inheritance. It's really the secret sauce for building smarter, cleaner, and way more reusable code. So let's get right into it.
I want you to just imagine for a second that your code isn't just a random bunch of files and functions. What if it could actually have a family tree? With ancestors and descendants all sharing a common lineage?
Well, that is the core idea behind inheritance. It's a system where new pieces of code can automatically pick up or inherit properties and behaviors from code that you've already written. This saves an incredible amount of time, and it really helps keep these huge, complex projects beautifully organized.
So what's the textbook definition? Well, when we get formal, inheritance is simply when a new class, we call this one the derived class, is created from an existing class, which we call the base class. The derived class, or the child, just automatically gets the features of its parent. It's that simple.
Okay, so why should you care? What makes this such a big deal? Well, it all boils down to a few massive benefits. Code reusability is the big one, right? You write something once in a parent class, and dozens, even hundreds of child classes can use it without you ever copying and pasting. It also gives you extensibility. You can add brand new features to a child class without touching the original parent code, which might already be tested and stable. This whole process naturally creates these logical hierarchies, and it just makes your entire project way more modular and so much easier to maintain down the road.
So to really get this, let's break it down to its simplest form: the basic family unit, the parent, and the child class.
Okay, let's get our hands dirty and look at some actual code. On the left, we've got a super simple animal class with an eat function. Now on the right, we're creating a dog class. The real magic is right here, that little colon, followed by public animal. That one line is what does it all. It tells the compiler that a dog is a kind of animal, and it should automatically get all of its public stuff.
And what does this actually get us? Well, we create a new dog object, we'll call it myDog, and here's the cool part: even though the eat method isn't written anywhere inside the dog class itself, our myDog object can still use it. That's inheritance in action. And of course, it can also use its own special method, bark. It gets the best of both worlds.
But just like any family, there are rules. You gotta have rules to keep things from getting chaotic. So let's dig into how this family of classes really operates.
One of the key rules is about managing access. We all know about public members, anyone can see those, and private members, which only the class itself can touch. But inheritance throws a new one into the mix: protected. You can think of these as family secrets. The parent class and all of its children can access them, but they stay totally hidden from the outside world.
Okay, so this leads to a classic chicken or the egg kind of question. When you create a child object, like our dog, both the animal part and the dog part have to be constructed. So who goes first? The order is super strict, and it makes perfect sense when you think about it. First, you have to build the foundation. So the parent's constructor, its setup function, gets called. Then the child's constructor runs on top of that. And when the object is done and needs to be cleaned up, it happens in the exact reverse order. The child's destructor goes first, and then the parent's. This just makes sure everything is set up and torn down safely every single time.
All right, we've got the ground rules down. Now let's look at the really cool ways you can start to structure these family trees. You'll see a few common patterns out there. Single inheritance is what we've been talking about. One parent, one child. Simple. Then there's multi-level, which is like a generational chain. A child inherits from a father who inherited from a grandfather. Hierarchical is more like siblings, where one parent, like animal, has lots of different kids like dog and cat. And then there's multiple inheritance, where one class can actually have two completely different parents. And yeah, this is where things can get a little wild. Speaking of things getting wild, that last one, multiple inheritance, can cause a pretty famous headache in the programming world. It's known as the diamond problem.
So picture this: you've got a child class D at the bottom. It inherits from two parent classes, B and C. But both of those parents share a common grandparent, A. You see how that creates this kind of diamond shape? That's the problem. So here's the issue, right? The child has now inherited everything from the grandparent twice, once through parent B and again through parent C. This creates an ambiguity. If the child tries to use something from the grandparent, which path should it take? Which version does it listen to? Thankfully, C++ has a really elegant way to fix this. By declaring the inheritance from the grandparent as virtual, you're basically telling the compiler, hey, I know this might get inherited through multiple paths down the line. Just Make sure there's only one single shared copy of A for everyone. And just like that, the family feud is resolved.
Okay, so beyond those main family structures, there are a few other special relatives that you should probably know about.
First, you have an abstract class. Think of this like a family blueprint. It's not a real thing you can create, but it sets down rules that all its children must follow, which is great for consistency. Then you have a friend class, which is kind of like the trusted outsider, the family friend who's given special access to the family's private secrets. And finally, a nested class is really just a helper class that's hidden away inside another one, a perfect way to keep related code tucked away and organized.
So when you put it all together, what is inheritance really about? It's about reusing your code, creating these logical hierarchies, and something called polymorphism, which is basically the magic that lets you treat different objects, like a dog or a cat, as the same general type of thing, an animal. And that power is what makes all this so incredibly fundamental.
At the end of the day, inheritance is a tool for modeling the world. It lets you represent really complex relationships in a clean, logical way. So the question for you is, now that you have this powerful blueprint for building code families, what are you going to create?